Welcome back to the Deep Dive. Today, we're plunging into environmental science. It's a field that's, well, not just crucial for our planet's future, but one that's constantly evolving, constantly having to meet these unprecedented challenges. Our mission, like always, is to pull out those really key nuggets of knowledge from the sources you've shared. So, okay, let's unpack this a bit. In a world where we're just bombarded with environmental headlines, how has the the definition and the scope of environmental science had to shift? How's it adapting to these really interconnected global issues?
That's a great place to start, actually, because that adaptability, that's central to its power. At its core, environmental science is it's about understanding these intricate feedback loops, often really surprising ones, between natural systems and, well, us,
Yeah.
human activities. And then the crucial bit is developing actual workable solutions for these huge challenges: pollution, climate change, biodiversity loss. They're all symptoms, really, of these complex interactions. It absolutely sets the stage for understanding our planet's future, not just how it is now, but how it's changing under pressure.
Right. So we know it's this big interdisciplinary field. It pulls from biology, chemistry, physics, geology, ecology, even the social sciences. But what makes that mix, that true blend, so uniquely powerful, or maybe uniquely complex when you're trying to tackle global issues? Is it just about having different experts talking, or is it like deeper about how the questions themselves get framed?
That's exactly the critical point. It's not just a collection of disciplines kind of sitting side by side.
Yeah.
It's the active synthesis of them.
Hmm.
Think about climate change, for instance. You've got atmospheric scientists modeling the carbon cycle, right?
Mhm.
But then ecologists are studying how forests or oceans absorb that carbon. And social scientists are analyzing, which policies actually work or don't work.
Mhm.
The real insight, the deep understanding, comes from seeing the feedback loops between all of those systems, things that a single discipline might just completely miss. That's the deep dive part, really. How a seemingly small change here can trigger these um, cascading effects across the whole system. It highlights vulnerabilities you wouldn't expect, or sometimes even synergies.
When you talk about this intricate dance, it could sound like this field must be ancient, as old as people thinking about nature. But surprisingly, modern environmental science didn't just sort of appear. It actually has this dramatic, quite recent origin story back in the 1960s and 70s. And it was spurred by events that, I mean, they literally shocked the world. Things like huge oil spills, you couldn't ignore the industrial pollution, and the devastating effects of pesticides. It sparked this kind of collective wake-up call. Our sources really point to books like Rachel Carson's Silent Spring. That was huge.
Absolutely seminal.
And the establishment of those foundational environmental laws, those were the moments that really kicked off systematic study and regulation.
And that collective awakening you mentioned, that's precisely why the field emerged when it did. It was this societal realization, wasn't it, that these problems weren't just isolated accidents. They were systemic issues. They demanded a structured, scientific, and importantly, a regulatory response. Public concern wasn't just a flash in the pan. It really necessitated this focused, informed attention. It pushed science out of the ivory tower and into the real world of policy and public health.
Okay, so we've got this spectrum: ecology, atmospheric science, environmental chemistry, geosciences, social sciences, policy, quite a range. But let's be real for a second. Putting all these brilliant people from different fields, different sort of silos into one room, does that actually lead to smooth collaboration all the time? Or are there inherent tensions, say, between a geologist focused on finding resources and a social scientist looking at the impact on a local community? How does this multidisciplinary thing actually work on the ground?
That is a fantastic question. And the answer is yes, absolutely. Those tensions exist. That holistic understanding we talk about, it isn't always easy to achieve, not at all.
Yeah.
It often involves uh, creating a shared language first,
Hmm.
building trust between disciplines, even challenging each other's basic assumptions about what a solution even looks like.
Right.
So, for instance, a chemist might come up with a brilliant new way to clean up pollution.
Hmm.
But then the ecologist has to weigh in on, okay, what's the impact on the local wildlife? And the policy expert needs to figure out, is this feasible? Is it fair to the people living there? True solutions, the ones that stick, they emerge from navigating that friction, not pretending it doesn't exist. But the fascinating thing is how these separate fields do manage to converge to solve problems that no single discipline could possibly tackle on its own.
All this complexity really brings us to the fundamental question for us, for you listening. Why should we care so deeply about environmental science in our day-to-day lives? It's definitely not just some academic thing. It plays these absolutely critical roles that touch everything from, the water we drink to the air we breathe, even the stability of our economies. It's fundamental to sustainability, giving us the knowledge to manage resources responsibly, thinking about future generations.
That's crucial.
It's vital for climate change mitigation, helping us pinpoint causes, understand impacts, and shape strategies to cut greenhouse gas emissions. It underpins ecosystem protection. Safeguarding those essential services we rely on, clean water, air, food, all that stuff. It has a direct link to public health, looking at how pollution or hazardous waste impacts our well-being. And finally, it's the bedrock for policy and governance. It supplies the scientific evidence that shapes laws, regulations, international agreements. It's huge.
And ultimately, the bigger picture here is that this knowledge translates directly into tangible benefits for society, for the planet. It's about way more than just abstract data points. It's about, like you said, breathable air, drinkable water, stable climates, thriving natural systems, the things that support all life.
Yeah.
It connects the scientific dots to actual real-world impacts we all feel.
Yeah. And when we talk about the Earth's health, a concept that's really taken hold lately is planetary boundaries. These 9 sort of vital processes the planet needs to stay stable. What's really striking, beyond just knowing they exist, is the ongoing scientific debate about precisely where those safe limits actually are for each one. And crucially, the compounding effect when multiple boundaries get crossed. Our sources highlight examples like climate change, obviously, biodiversity loss, freshwater use, chemical pollution.
Right.
And the really sobering part, recent assessments show multiple boundaries have already been crossed, which signals this urgent need for global action to try and avoid irreversible environmental damage.
Exactly. And it's not just like a static checklist, is it? It's a dynamic, interconnected system. Crossing one boundary, let's say, biodiversity loss doesn't just impact biodiversity. It can destabilize other boundaries, like freshwater cycles or climate regulation, in ways we're, frankly, still scrambling to fully grasp.
Yeah.
The urgency isn't just that we've crossed them. It's the unknown cascading risks that pop up when human activity pushes multiple Earth systems beyond their stable operating zone.
Right.
It raises a really profound question about the responsibility we all share, doesn't it?
It really does. So, okay, with all these complex challenges, these interconnected systems, how do environmental scientists actually gather and analyze all this critical information? What are the tools, the techniques they're using today?
Well, they're leveraging some incredibly sophisticated approaches now. Think about remote sensing and GIS, geographic information systems. That lets us map and monitor changes from space. We get this bird's eye view of deforestation or melting glaciers or urban sprawl. They use powerful computer models to simulate things like climate patterns or how pollution spreads or how ecosystems might react to change. It allows us to project future scenarios, which is vital for planning.
Right, like what-if scenario.
Exactly.
Yeah.
Then there's the sheer power of big data and artificial intelligence. Analyzing these vast data sets to find patterns, make connections that, frankly, a human brain might just miss. That helps environmental decision-making enormously. And, of course, you can't forget the foundational field research. Scientists out there actually gathering real-world measurements, testing soil, water, air quality, tracking wildlife.
Yeah.
That provides the ground truth, a reality check that anchors all the modeling and remote sensing.
Gotcha.
All these methods together, they enable a much deeper, much more precise understanding of environmental systems than we've ever had before. And that supports truly evidence-based solutions.
And if you're maybe listening and thinking about a path forward, environmental science offers incredibly diverse career options. You could be an environmental consultant, a conservation scientist, a climate analyst, an environmental engineer, a policy advisor, maybe a sustainability manager, or an environmental educator. Loads of options.
Well, yeah.
And professionals work everywhere, government agencies, nonprofits, research labs, private companies. But beyond specific careers, the urgency is just undeniable, isn't it? These environmental challenges are getting more complex, more tangled up together. Climate change, habitat destruction, pollution, resource depletion.
Yeah.
These aren't separate problems anymore. They genuinely threaten global health, economies, even security.
What's maybe the most surprising skill or, I don't know, mindset you've seen in successful environmental professionals, something that maybe isn't always taught in a textbook? That's a great question. And I think I'd say it's the ability to translate incredibly complex scientific information into insights that are actionable, that are understandable for non-scientists. It's almost like the art of storytelling, but with data. convincing diverse groups, policymakers, business leaders, local communities that yes, this problem is real, and yes, this proposed solution is viable and fair.
That communication piece.
Exactly. Environmental science gives us the essential tools to understand the challenges, yes, but maybe more importantly, it helps us design solutions that effectively balance human needs with, well, with those planetary limits we talked about. It really underscores the increasing need for science-driven leadership, doesn't it? And for robust international cooperation and for real community engagement if we're going to navigate these complexities successfully.
So to sort of wrap it all up, environmental science is just absolutely vital. Vital for protecting Earth's ecosystems, vital for ensuring a sustainable future. It integrates knowledge across so many different fields and applies it to these tough, real-world challenges, helping all of us make more informed decisions for the health of the planet and really for all of us inhabitants.
And stepping back, thinking about the broader implications. While environmental science gives us the understanding and the tools, it also, I think, profoundly empowers each of us, whether it's through our daily choices or maybe how we advocate for change or even our career paths. Understanding these planetary limits enables all of us to contribute to that collective effort to work towards a truly sustainable future. It's not just for the experts anymore, it's really become a shared responsibility and one that's informed by shared knowledge.